So least square regression. A residual is a vertical line. Is the vertical line distance between the data point and the graph of the regression equation. Okay. So this is the line of best fit right here. Okay. The residual is the vertical distance between the data point and the actual regression line. So as you can see, the residual is the space in between that point and the regression line. If the residual is positive, the point is above the graph clearly. The residual is negative if it's below. The residual is 0 only when the graph actually passes through the data point. So say there was a point right here, the residual will be 0. Okay, makes sense, yes? Okay. Now, this all comes into play when you're trying to find the equation for your slope, okay? This is the formula here to find the slope of your regression line. This is the equation we use to find the equation of the slope. Yes. Okay, so the slope of that line is capital S sub xy over capital S sub x squared. And then you have what S sub x and S sub x squared represent. Okay?
So it's the sum of x.
Means the sum, okay? The sum of x times y minus the sum of your x's times the sum of your y's all over n. N represents the same n that it represented before, which is what? Number of stuff, number of pieces of data, okay? And then of course your squares. Alright? Everybody has this written down?
Yes.
Okay, we're gonna find it by hand and then we're gonna do it using your calculator on the next one, okay? So this one we're gonna do by hand. It says use the least square regression formula to find the equation of the regression line through points 1, 3, 2, 1, and 3, 5, okay? So first off, let's identify what my x's are and what my y's are, okay? My x's are what? 1, 2, and 3. What are my y's? 3, 1, and 5, okay? And so, the formula okay, that's your formula to find your slope. Okay? Now I could keep flipping back and forth, but hopefully you guys wrote it down, right? So I don't have to keep flipping. Okay, so S sub xy was the formula. It was the summation of what?
X and y.
The summation of x and y together. So we gotta do x times y. Okay? What's x times y? 3, 2, and 15. So what's the sum of all those? 20. Okay, so there's 20. And then we have to subtract it, right? From what?
Aren't we subtracting something else from it?
Well, what's the rest of the formula?
Sum of x times sum of y, which is 6 times 9.
Sum of x times sum of y. Okay, so the sum of x is 6. Sum of y is 9.
Which is 54.
54. So we gotta multiply those together.
54 over n.
N.
Is a number of stuff, so we have 3 stuff.
We got 3 points.
Yes.
So we're gonna divide by 3. So all this is over n, so we're gonna divide this by 3.
And that's all over the other part.
And that's all over the other part. Well, let's figure out what this is. What divided by 3 is?
I'm doing it right now.
18. So what's 20 minus 18? 2. So that numerator is 2. Now we gotta do this bottom part, which is represented by what? What's the formula?
That's the sum of x squared minus the sum of x squared over n.
Okay. So the sum of my x is squared, which is what?
36.
36 minus
36 over 3, which is 12. 36 minus 12, 24. So 2 over 24 or 112.
So there's my slope. There's going to be the slope of the line, of the regression line, least squares regression line. Okay?
So in our y equals mx plus b, that's our n.
Yes. Sorry.
So we just plug in the point.
So then we take that, we take one of our points, and we write our equation. Does not matter which points, it does matter which points we use here, okay? Because remember, all these points are around this line of best fit. What point lies on this line that we know for sure? What point lies on the regression line that we know for sure? No? Think about it, the other problems that we did, when we drew the regression line, what point did we always draw the regression line to? The mean. So the point that we're going to use to write our equation is the mean. So what's the mean of my x's?
What were the total 3, 2?
What's the mean of my y's?
9 divided by 3. 3? Oh.
Because it's 3 points. So this is the slope, and this is the point that we're going to use to write our equation. So y minus
Y, 3 is equal to mx plus, to 1/2 times 2 plus 2. Oh, you're doing it that way?
Yeah.
Oh, okay.
Sorry.
X minus 2.
And then of course you can distribute and then add 3 over to get the line in slope intercept form. And then that would be your equation. Okay? This is how you do it by hand. To my understanding, these formulas are in your reference book, so it's not like you have to sit here and memorize them. Okay? I believe. If they're not, then you would have to memorize them. But it's pretty simple, okay? Making a nice little chart here, you know, and then it makes it a lot easier for you to see. Okay? Questions? Alright, let's look at the next one. This is how you would do it by hand. Let's look at one where you don't do it by hand, okay? You have your situation. It says, the table shows the distance in kilometers of airfares in US dollars from Shanghai Airport, Singapore to 12 destinations. Use your graphing calculator to sketch the scatter diagram of this data. Graphing calculator. We gotta use our table here. What do you think I wanna plug in the L1?
Distance?
The distances, okay? So go ahead and type those distances in to your calculator. One more time the L2. The fair. So you gotta type in all of your data.
What does flow mean?
It means like it does the rounding for you. So you wanna round it to decimal places and do that.
Oh, we're changing our flow?
No, we're not. She just asked.
Oh.
Alright, so ready? Let's look at this stuff. Let's look at this data. Okay? Go to y equals. Okay? Clear out any other equations that you might have in there. And what I want to do is I want to turn my plot on. Okay? So to do that, you just go up to where it's highlighted and click enter. If you want to do it more specifically, you can press the second button and you can press the y equals button, and then what it does is it takes you to all your stats possible, and then of course you can turn it on, change the type and everything like that, okay? So you want to make sure it's on, and it's looks like this to show scatter. Okay? So then all you do is you press zoom, you press stat, and then there's your data. Everyone's data showed up, yes?
Zoom and then stat.
Uh-huh. You gotta make sure your stat plot's on, or else it's not gonna show up. Okay? So go to y equals, make sure plot 1 is highlighted, press zoom, and then go down to zoom stat. Mine's number 9, so I just click 9.
Okay, so it's highlighted, so I'm gonna zoom.
9. Mm-hmm.
Oh, zoom 9.
Yeah, zoom.
I literally clicked the button stat.
Okay, so everyone has the scatter, right? And there it is, okay? So if you wanted to sketch it, there you go. You have something on what it should look like once you sketch it, okay? Now it says write down the equation for your line of best fit. To find that out is even easier. To calculate this all the work. All you do is you go to stat to find the regression line. You go to stat, go over to calc, go down to lin reg. That means linear regression. AX plus B. Sound like MX plus B, right?
Oh.
You click enter. Now if yours pops up like mine, you want to make sure, Stephanie, use yours like mine?
Yep.
Okay, so you want to make sure that it says L1 in X list, and L2 in Y list. Stat, go over to count, go down to lin reg. Okay, now if yours doesn't look like this, hold up real quick and just go all the way down to calculate and press enter. Now for everybody else, if your calculator doesn't do this thing, yours is simple. All you do is you press second, go over to count, go down to lin reg, L1, comma, L2,
Enter.
enter.
Then it gives you your A and your B.
And it gives you your A and your B. Okay? Now, recently I've had the tendency to not type in the right
No, you
thing.
got it, you got it.
Okay. So my slope is this.
3 sig figs, right?
3 sig figs, so it's going to be y equals, or about 0.117x plus 83.3. And there's my line of best fit.
Yay.
All right?
Okay, can we go over one more time? How to do this?
Yep.
I just want to write it down.
So you type in all your data. So remember, you got to press stat and edit. You type in your data. You go into y equals, make sure plot 1 is on. Now plot 1 should only be on if you're doing stuff dealing with scatter plots regression line. If it's on and you're trying to just graph a quadratic, it could really mess you up. It could read an error message and all types of things, okay? So make sure it's only on when you need it. Then you go to zoom 9 to look at your data. And then you press stat, go over to calc, down to option 4, which is lin reg. Enter. Make sure it's L1, comma L2. Or make sure L1's in X list, L2's in Y list. And calculate. And there it goes. Okay? Now, more than likely, they'll probably have you do this type, let you do this type of stuff in your calculator for your exam. So you want to make sure that you remember these steps, okay?
I'm not too hard.
And then part C says what? Use my equation to predict what?
Estimate the cost of a 1,000 kilometer flight.
A 1,000 kilometer flight, okay? So if it's a 1,000 kilometer flight, is that my X or is that my Y?
That's your X.
That's my X, because that represented distance, didn't it? So all I do is plug in. So 0.117 times 1,000 plus 83.3, and I'll figure out how much my fare is.
Well, that's 1,000 because of decimal points. So it's 117 plus 83.3, which is 200.3. Excuse me, 200.3.
So it's 200.3?
Yeah. Is that what everybody else got? Or 0.30 because it's.
It is money.
200.3.
200.3. And this is measured in, does it say? Yep, US dollars.
Do we put a dollar sign?
I always go with USD. Just to be sure. Alright?
Will we put 0.30 or would that be marked wrong?
30. Alright? Questions? Simple enough?
On standard deviation,
Uh-huh.
we plot in both x and y, and it does the same with me.
Uh-huh.
When is there an occasion where
only do L1 or L2 when it's.
When it's just like one piece of data, like if we're just looking for, like, say just give us a list of all these scores and they want us to find the mean. That's the only time we use just L1 or just L2.
But for the example of the work and the final score, if it just asks for the mean of the final score, that's the only, the L2 or
That's just the L2,
okay.
yeah.
But other than that, it's always both of them when we hit calculator.
Yes. Here, correlation. Okay, we talked about that before. Okay, correlation basically told you how strong, how weak your data was. Okay. Well, there is something called the Pearson product moment correlation coefficient, which is denoted by R. Is the measure of the correlation between your two variables, x and y. And this number falls in between 1 and -1 inclusively. If you recall when we first did correlation in those graphs and those pictures I gave you, there was some like R equals a number, R equals whatever. That basically told you the types of correlation you can have, and I did mention this before. There is a way to determine if it's weak, very weak, moderate, and strong. And that's if your correlation coefficient, your R, lies in between these intervals, okay? So it's already written down for you. So, to figure this out by hand is this formula here, okay? The same S sub xy, and this time it's over S of x and S of y, okay? These are your formulas here to figure out R by hand. And this example we're going to look at, not going to have time to do it by hand, so what I'll do is I'll record a video of me doing it by hand, and I'll do it with the calculator with you guys right now. So go ahead and get this down. And we're going to look at the next example.
Oh, it's recording?
Yes.
It records a voice too?
Yes.
Really?
Yes. All right. You guys got it? You guys get it?
Just your voice?
No, your voice too.
Oh.
All right, here we go. So this example, I don't think I have it written down.
Sue wants to determine
Yep. Sue wants to determine
the strength of the correlation between the number of spoons of plant food she uses and the extra number of orchids grown from a plant.
we have to use the correlation coefficient formula to interpret the relationship. So interpret, that means actually describe it as a strong, weak, positive, negative, whatever. So here we go. We're actually going to go into our calculator and type this in. This is our data here, okay? So we got to go back to our calculator, go back to stat, go back to edit, okay? So we're going to clear out our tables. Remember, you go up, highlight L1, press clear, goes away, okay? And then we're going to type in our data here. We're going to type in our data. Two, 3, 8, 7.
Yeah.
Oh no, not 30.
Okay? Then you want to go get out of the screen. Go back to your home screen. Second mode, okay? Anytime you want to do anything else, try to get out of that screen, or else if you try to go like straight to linear regression equation or anything like that, it's gonna do it inside of the table. If you press delete, it deletes everything. Okay, and that's not what you want. Alright, so then from here, all we have to do, just out of curiosity, when we did the len reg before, did you guys already have R on your calculator? Crap. Everybody do this right now. You remember when we did linear regression for that last example, right?
Yeah.
Did it just show you A and B, or did it show you anything
Just
else?
A and B.
Okay, so when that happens, because that's the default. That's the default setting. So when they reset the calculators for the exam, you're going to have to turn this on. You press the second button, you go down to 0, which brings up a catalog of all the options that are in this calculator. You're going to press D, which is this x to the -1 button. It takes you straight down to the D's. Then you got to go to diagnostic. So scroll down till you see diagnostic on. Scroll all the way down.
I remember this.
Okay, diagnostic on. You click enter. You click enter again. So now everything is turned on when it comes down to your linear regression, including your correlation coefficient. So all you do is you find your linear regression line again. You go to stat, go over to calc, go down to lin reg. Make sure it's L1 and L2, so L1 comma L2 for those who don't have this option. Click enter, and what should happen is you should have more information than just A and B.
And we're looking for the R, right?
And we're looking for the R. R tells us our correlation coefficient. It's going to tell us how strong this data is. Okay? So rounding to 3 significant figures,
0.877.
my R is 0.877. And if you recall, 0.877 is strong. And is it negative or positive? So this is a strong, positive relationship between the number of scoops and how many plants grow. Okay? Questions? Because the R was positive. Okay? So, your homework is attached to those notes, okay? We're getting questions, preparing you for your quiz that's sitting tomorrow.